So for the converse of the Pythagorean theorem, first thing we should kind of try to understand is what's a converse. I know, right? It is not a shoe company that got bought out by Nike in this case. It's something different. Converse is, well, let me just write it down. It's when you reverse the if and then in a statement. Okay, so when you reverse the if and the then of a statement, it's funny that someone mentioned shoes because when I first learned about Converse, that's the first thing that came to mind to me. It's the shoe company. Okay, let me give you an example. And it's the example we talked about before we started the notes. So here is an example. First, the statement. I'll write that down. And the statement's going to be, if a shape has three sides, then it's a triangle. That's what we call the hypothesis. The hypothesis in this case is the statement that comes after the if. A shape has three sides. The conclusion is the part that comes after the then. And that would be, it's a triangle. Get another color. The screen will stand out from that. Okay. So there's my original statement. Let's flip it. So the converse is going to say this. We start with an if statement still. If, and so we're going to write this part over here. If it's a triangle, then it has three sides. We should say it's a shape. Okay. There we go. And in this case, we established that both of them are true. Both of these are true statements. Okay? And when they are in math, it's a very powerful concept. And it just so happens that the Pythagorean theorem is the same way. Remember we said the Pythagorean theorem is if you have a right triangle with legs A and B and hypotenuse C, then a squared plus b squared equals c squared. That's a Pythagorean theorem. You start with a right triangle, then you get this relationship between the sides, a squared plus b squared equals c squared. Well, if we reverse that, we have the converse of the Pythagorean theorem. Let's just write that down. Okay. Converse of the Pythagorean theorem. And we're just going to reverse our hypothesis and conclusion. Our hypothesis was for the Pythagorean theorem was you have a right triangle. The conclusion was a squared plus b squared equals c squared, right? So let's reverse those. If, let's just say a squared plus b squared equals c squared. We should say if the sides of a triangle follow a squared plus b squared equals c squared, then what kind of triangle is it going to be? But what type? A right triangle. So what this means is we can determine if a triangle is a right triangle without even looking at it or measuring its angles. All you got to know is the length of the sides and then just do this math. On yesterday's activity when we were doing the find it, fix it, those of you that went to card number 7 and number 10 actually asked you to do this. And quite a few of you got it right. So, and I did drop a few hints for a few groups. So basically, if you have the sides of a right triangle and it's a squared plus b squared equals, if you have the sides of a triangle, it's a squared plus b squared equals c squared, then we know we have a right triangle. And we can actually figure out a little more than that. So I'm going to just extend this, and we're going to have more conclusions. So these are all the conclusions we get from this statement. So it's not just a squared plus b squared equals c squared. We can actually determine also if we have obtuse or acute triangles. Okay, so here we go. Let's say we have a squared plus b squared, and it's greater than c squared. So what we're saying is this is the bigger side. A squared plus b squared is going to be bigger than c squared. Well, turns out that we have an acute triangle. Over. So the conclusion here is we're going to end up when it's greater, we have an acute triangle. You all know what an acute triangle looks like, right? All the angles are smaller than 90 degrees. Okay. Then we have, of course, the Pythagorean theorem, a squared plus b squared equals c squared. And that's going to be a right triangle. Okay. So the conclusion when it's equal right triangle. And we have one more possibility. A squared plus B squared is, we did greater than, we have equal to, all we need is less than C squared. Turns out that if that's the case with the sides of a triangle, you have an obtuse triangle. So one of the angles will be bigger than 90 degrees. So we're going to practice this a little bit. Okay. I'll let you write that down, kind of take it all in. So now we know if we have when a squared plus b squared is greater, equal to, or less than. And we're going to practice this a little bit. I'm going to give you the dimensions of a triangle, and we're going to have to decide what type of triangle we have. Okay? So over here, let's write down dimensions. And we'll make a column for that. Just all the way down. We're going to do a little bit of work. We'll come up with a conclusion. And finally, we'll make a small sketch. Okay. All right. So the important part is I'm going to give you three sides of a triangle. The largest of the three sides always has to be our C value, okay? So here we go. Let's say the sides are 30, 15, and 45. 30, 15, and 45. So we're going to assign them a label of A, B, or C. Which of these three sides has to be C? 45. So this one is there. And then the other two, we'll call 30A. It's an acute triangle. Let's see here. I'm going to do A squared plus B squared. And then C squared. And so we have 30. We'll square it. 15. We'll square it. And 45. We'll square that. Okay. Let's see. 30 squared is 900. 15 squared is 225. And 45 squared is 2025. So which one is bigger? The 900 plus 225 or 225? Which one is bigger? 225 is going to be bigger than that. So remember, the crocodile eats the bigger number. Which case do we have? Acute, right, or obtuse? Obtuse. Turns out we have an obtuse triangle. Okay, so let's make a quick sketch of an obtuse triangle. Big opening usually. something like that. So there's my obtuse angle. So let's say this is 15, 30, 45. Okay. Okay. Let's move on. Let me give you three more sides. 21, 15, and 17. 21, 15, 17. All right. So which one has to be C? 21. That's our biggest side. So we'll call these A and B. And let's go back to A squared plus B squared and C squared. So we're going to do 15 squared plus 17 squared, and then 21 squared. So we got 225 and 289, and then 21 squared is 441. So which one's going to be bigger? Oh, we have to add these, by the way. 225 plus 289 or 441? Yeah, it's actually 514. And this is 441, obviously. So the bigger number is here. And the crocodile eats the bigger number. So we have what kind of triangle? Acute. Okay, so for an acute triangle, none of our angles can be bigger than 90 or more than 90. Something like that. Okay, let's say this one's 21 because it looks kind of biggest. 15, 17. Okay. So this is number 1, number 2, number 3. We got 2 more, including the one we're about to do. Okay, 24, 18, and 30. 24, 18, 30. Our largest side is 30. So that'll be C, A and B there. Okay. So let's set this up. A squared plus B squared and C squared. So that's going to be 24 squared plus 18 squared and 30 squared. So let's see, 24 squared is 576. 18 squared is 324. And 30 times 30 is 900. And lo and behold, if you add 576 and 324, you get 900. So this time they're equal. Oh, should have done it in red. And because they're equal, a right triangle. Well, finally, we can draw a right triangle. Maybe something like this. This side is 30. Let's say this is 18 and 24. Okay, we'll do one last example. This is going to be number cuatro. Let's do 7.5, 12.5, and 10. Okay. So which one is our longest side? 12.5. So this has to be C, and we'll make these A and B. All right. So A squared plus B squared, we'll compare it to C squared. So we want 7.5, and we'll square that. 10, we'll square that, and 12.5, and we'll square that. Okay, 7.5, 7 squared is 49. It has to be a little more than 49, so it's actually 56.25. What was that? 56.25. Let's just do the whole thing. And then 12.5, it's 12.5 times 12.5 is 156.25. And what's our conclusion there? Yeah. They are equal. So lo and behold, another right triangle. Let's say this is 10, 12.5 since this is a little bigger, and 7.5 goes here. Okay. So on today's Delta Math, I'm sorry, not Delta Math, we're doing an IXL. On today's IXL, this is what we're going to be doing. They're going to give you 3 sides of a triangle, and all you have to decide there is, yes, it's a right triangle, or no, it's not a right triangle. It won't even get into is it acute or obtuse, but I figured since we get that as part of the theorem, we should explore that anyways. All right, guys. So the assignment is on IXL.